welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In this episode, we are going to dive into a critical part of application security, code review, and the two primary types of testing, static testing and dynamic testing. If you are studying for the Certified Information Systems Security Professional certification, it is important to understand how software vulnerabilities are discovered, analyzed, and corrected. Secure coding practices are essential, but they are not enough on their own. Security professionals must also test and review software thoroughly to ensure that applications are not only functional, but also secure. In this session, we will explore how manual code review, static application security testing, and dynamic application security testing each play a unique role in securing software and why combining them offers the strongest defense. Let us start by understanding what these processes are and why they matter. Code review and security testing are formal processes used to evaluate software applications for vulnerabilities, design flaws, and implementation errors. Whether you are reviewing source code line by line or running automated scans, the goal is the same: to detect security issues before they can be exploited. This includes everything from simple coding mistakes to deeper flaws in business logic or application behavior. Security testing is essential because vulnerabilities in software often lead to data breaches, system compromise, or even full-scale attacks against an organization. Attackers frequently target applications because they are complex, constantly updated, and often overlooked from a security standpoint. Testing provides a structured way to find those weak spots and fix them. A solid application security program includes manual code reviews, static testing, and dynamic testing. Each method has its strengths and limitations, but together they help an organization reduce software risks, meet compliance standards, and build trust in their digital systems. Let us now take a closer look at manual code reviews. This type of testing involves real people, usually software developers or security analysts, reading and evaluating the source code of an application. The purpose of a manual code review is to identify problems that may not be caught by automated tools. This could include subtle security issues, logic errors, or places where coding best practices have not been followed. Manual reviews offer several key benefits. Because they are performed by humans, they allow for deep understanding of the application's purpose, logic, and structure. This helps in detecting issues that are highly context-specific. For example, a human reviewer might notice that user input is not properly sanitized in a certain part of the code, even though the rest of the application follows input validation best practices. A manual reviewer can also identify misuses of authentication routines, improper error handling, and coding patterns that introduce security concerns. However, manual reviews are not perfect. They are time-consuming and labor-intensive. Reviewing a large application manually can take weeks, and there is always the risk of human error or oversight. The effectiveness of a manual review depends heavily on the skill and experience of the reviewer. Two people reviewing the same code may not identify the same issues, but despite these limitations, manual code reviews remain a powerful method for discovering nuanced and complex vulnerabilities that automated tools might miss. Next, let us explore static application security testing, often referred to as SAST. Static testing is performed without running the application. Instead, the tool scans source code, bytecode, or binaries to detect potential security issues. SAST tools analyze the structure of the code, looking for known patterns that indicate vulnerabilities, such as insecure function calls, buffer overflows, or improper handling of user input. The biggest advantage of static testing is that it can be done early in the development process. You do not need a running version of the application. This means developers can get feedback on their code before the application is even deployed. This early feedback loop allows vulnerabilities to be caught and fixed before they reach production, saving time and reducing risk. Static testing is also scalable. Tools can scan thousands of lines of code quickly and consistently. It is relatively easy to integrate SAST into a software development pipeline, allowing scans to run automatically. whenever code is checked in or updated. However, static testing does have some drawbacks. Because it does not observe the application running, it cannot detect runtime-specific issues like misconfigured web servers or user interface flaw. It can also generate false positives, flagging code as vulnerable when it actually is not, especially if the tool is not configured correctly. Still, when used properly, SAST provides a strong foundation for early-stage vulnerability detection. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Let us now turn to dynamic application security testing, or DAST. This type of testing analyzes an application while it is running. The idea is to simulate attacks and observe how the application responds. DAST tools do not need access to source code. Instead, they act like an external attacker, probing the application for weaknesses by sending crafted inputs and analyzing the outputs. DAST is considered black box testing because it does not rely on internal knowledge of how the application works. This makes it ideal for testing how applications perform in real-world environments. It is particularly useful for finding vulnerabilities related to input validation, authentication, session management, and server misconfiguration. For example, a DAST tool might discover that an application accepts unfiltered input in a web form and is vulnerable to cross-site scripting attacks. One of the strengths of DAST is its ability to identify runtime vulnerabilities. These are issues that only appear when the application is live and handling real user interactions. DAST can also provide a realistic picture of how an attacker might exploit the system. However, there are limitations. Because DAST tests a running application, it can potentially disrupt production systems if not properly controlled. It also struggles to find issues that are deeply embedded in code logic or internal application flow. Furthermore, DAST might miss vulnerabilities if it cannot reach all parts of the application during testing. Despite these limitations, dynamic testing is an essential part of a robust security strategy. Now that we have explored manual reviews, static testing, and dynamic testing individually, let us talk about how to combine them for maximum effectiveness. Each of these methods addresses different types of vulnerabilities and offers different strengths. When used together, they provide complete coverage of the software development. Manual reviews offer detailed, context-sensitive analysis. Static testing offers early, automated vulnerability detection. Dynamic testing provides real-world validation of how an application behaves under simulated attacks. By combining all three, organizations can detect security issues at every stage, from the first lines of code to the live application. This approach also improves scalability. Automated tools handle the bulk of routine testing, while human reviewers focus on complex or high-risk areas. It also improves accuracy. Issues found by one method can be cross-validated by others, reducing false positives and negatives. Integrated testing workflows allow security and development teams to respond to issues quickly. When tools and processes are aligned, vulnerabilities can be identified, analyzed, and resolved more efficiently. This not only reduces security risk, but also helps organizations meet compliance requirements and maintain a strong security posture. Continuous improvement is also essential. Just like other parts of cybersecurity, testing strategies must evolve. Regularly reviewing and updating testing methodologies ensures that they remain effective as threats, technologies, and regulations change. Lessons learned from past incidents and testing outcomes can help teams fine-tune their processes. Cross-functional collaboration is also key. Developers, security analysts, operations staff, and compliance officers all have a role to play in application security. Working together ensures that testing is not just a one-time task, but an ongoing part of software development and maintenance. Regular training keeps everyone sharp. Developers need to understand secure coding practices. Testers need to stay up to date on the latest tools and techniques. Leaders need to support a culture of continuous improvement. Finally, effective security testing is not about checking boxes. It is about building secure, reliable software that users can trust. By investing in testing, Organizations make their systems stronger, their users safer, and their operations more resilient. Thank you for joining the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Deepen your understanding of code review, static testing, and dynamic testing, and will consistently support your journey towards CISSP certification success.